Welcome to FM Education Academy, a place where quality content is provided to all students. It is on your request that we provide educational videos daily. So please, if you find this video helpful, then like this video, share this video with your friends, and also please subscribe to this channel and turn the bell notification on. In today's video lecture, we will be discussing a question which is find out if it is a surjection, injection or bijection. This is a second bit from second Roman of exercise 1A for MPC and MEC students of the chapter 1 functions from exercise 1A here in intermediate first year. In the last lecture we had done first bit. In today's lecture we will be finding out whether a function f of x is equals to 2 power x. Okay, it is a injection or is it a surjection or is it a bijection, and the interval is given to me where that for x should lie between 0 and infinity, that is all the positive values. And in order to find out whether a function is injection or not, we know that we have the formula if f of x1 is equals to f of x2, then x1 should become equal to x2. So we'll apply this formula and find out whether a function is injection or not, this function. So to find out whether it is injection or not, we have f of x1 is equals to f of x2. In place of this x, I will write x1 and x2. So 2 power x1 is equals to f of x2 is 2 power x2. Now we know that these are called as bases and x1 and x2 are called as powers. And we know we studied in school that if bases are equal or if bases are same, then powers are equal. So here bases are 2 and 2 means powers are equal. So we got to know that x1 is equals to x2. So we had assumed that f of x1 is equals to f of x2 and we got x1 is equals to x2. It means that f of x here is an injection. That is the formula which we have for finding out whether a function is injection or not. Now to find out whether a function is a surjection, we have to assume that this let y is equals to f of x. Okay, so we are assuming that let y is equals to f of x. If y is equals to f of x, then we have y is equals to 2 power x. And if a power x is equals to n, if a power x is equals to n, that is this, we can write this as 2 power x is equals to y. Okay, I am just interchanging RHS to LHS and LHS to RHS. That is, I am writing y is equals to 2 power x as 2 power x is equals to y. And I know that I have a formula. If a power x is equals to n, then x is equals to log n to the base a. That formula only I am going to apply here. I have 2 power x is equals to y. So I know that x is equals to log y to the base 2. So x is equals to log y to the base 2. Now what I will do, what function I have, that is f of x. Okay, f of x is equals to 2 power x. In place of this x, I will substitute this value and I will find out whether I am getting y is equals to f of x or not. If I am getting y is equals to f of x, then I can say that it is a surjection. Now substitute this value of this x which we got in this function of f of x, which is nothing but 2 power x. So 2 power, what is x we have? Log y to the base 2. Now we know that in class 10th we read a formula that 2 power log n to the base a. 2 power log n to the base a is nothing but n only. Okay, so here 2 power log y to the base 2 is same as 2 power log n to the base a. So what is n here? Y. So we got that f of x is equals to y. What did we do to find out whether a function is surjection or not? We have assumed this f of x equal to y and we got the value of x. After getting the value of x, find out f of x again and see whether you are getting f of x is equals to y or not. So here we got f of x is equals to y. So I can say that here f of x is equals to 2 power x is a surjection. Now how to know whether a function is bijection or not? We know that if a function is an injection as well as if a function is a surjection, we know that it will be a bijection. So we'll write, since f of x is an injection and surjection, therefore f of x is also a bijection. So this completes our second bit. If you have found this video helpful, then please like this video, share this video, and please subscribe to this channel and turn the bell notification on. Thank you.